In the last example, we had velocity that was constant over various intervals of time. And when the velocity is constant, because it's the rate of change of displacement over time, what we get when we graph the displacement over time is just straight lines. So we had um, a velocity graph which is just made up of straight lines. Okay, but as you can imagine, the velocity is not always constant. Velocity could be increasing or decreasing, and in that case, when we graph the displacement over time, we're going to get a curve. Okay, so in this example, we're going to look at these at what happens when we have a curved displacement over time. All right, and I've got an example of each type of concavity, right? So so let's just take a look at this first one. In this case, displacement from the point of reference, displacement is increasing, right? It's increasing. So the velocity is positive. Okay. And whoops, all right. Now the velocity, what's happening with the velocity? The velocity, if I look at the tangent lines here, right, you can see, okay, maybe a tangent line like that down here is fairly shallow, whereas it seems to be getting steeper, right? Velocity in this example is increasing. Increasing. So the acceleration, if velocity is increasing as time is increasing, right? The acceleration is the rate of change of velocity, right? So we have positive acceleration, positive acceleration. Oops. All right. Positive acceleration, right? Because the velocity is increasing, right? It's increasing. It's becoming more positive. We have positive slopes, and they're becoming more positive. So, is the object, what's happening here? I didn't put a choice here, but it's actually speeding up, right? Because the velocity is positive and getting more positive, so it's speeding up. Okay, velocity is positive and becoming more positive, so it's speeding up. All right, displacement. Sorry, in this next one, we have a different curvature. It's concave down now. So the displacement is decreasing. Right? We're getting closer and closer to wherever the point of reference is. Right? So getting closer and closer to home or the origin or whatever our point of reference is. So that means that velocity is negative. Velocity is negative. Right? You can also tell just by if I drew tangent lines at various points, the velocity is, the slope is negative, right? Down here, the slope is even more negative. If I draw a tangent line, it's kind of hard there. Let's draw a tangent line. So now the velocity, you can see that it's negative and becoming more negative. So we would say that velocity is decreasing, right? Because it's becoming more negative. Okay, so acceleration is negative. Okay, does that make sense? It's just because these slopes are becoming more negative, which is essentially decreasing. All right. So, but if you think about whether the object is speeding up or slowing down, right? So again, speed is just the absolute value of the velocity. So the slope here is negative, but if you take the absolute value of it, it's a smaller number than it is down here, where the slope is negative, but it's more negative. So the absolute value is going to be larger. All right. So this object is speeding up. All right. So this would be an example, if you look at this displacement over time, of something falling under the acceleration of gravity, right? Where you drop something off the roof of a building, And initially it's going at initially it's zero, right? The velocity is zero when you drop something off of a building, and then it's falling in the downward direction, and so the velocity is negative, but it's becoming more negative, and it's accelerating, and then until it hits the ground. Whereas in this first example, where we had this other example here, where we had the curve that was concave up, this would be like maybe a rocket taking off from the ground. Initially, the velocity is zero, the engines fire in the rocket, and it gets faster, 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 right? It's speeding up. Okay. Okay, so let's look at the next one here. Here, we've got a couple more curves here. Here, the displacement is, okay, we just want increasing or decreasing, right? So you can see that the distance is increasing, right? The distance from the origin is increasing. So the displacement is increasing. Okay, displacement from the point of reference is increasing. That means that the velocity is positive. And we can also tell that by looking at slopes, the slopes of tangent lines, right? Those are all going to have positive slopes. Right? Now, the velocity, if you look at the slopes, you can see they're all positive, and it's becoming less positive, right? The slopes down here are steeper than these slopes up near the top here as time goes on. And so the velocity is decreasing. Okay, so what does that mean about acceleration? If the velocity is decreasing, right, the change in velocity over change in time is negative, right? So that's acceleration. So the acceleration is negative. Okay. And, okay, is the object speeding up or slowing down? Now, the velocity is positive, but becoming less positive, right? So then it's slowing down. Slowing down, right? It's slowing down. The velocity is positive and becoming less positive. So it's slowing down. All right, in this last graph of displacement over time, you can see it's concave up, but decreasing, right? So the displacement, right, we're getting closer and closer. The distance from the point of reference is decreasing, so displacement is decreasing, right? So what does that mean about the velocity? The velocity is negative. Okay, and you can tell by if I draw tangent lines, right? If I draw a tangent line, it's negative. Tangent line down here would also be negative. It's just a little less negative, okay? So the velocity, all right, it's negative and it's becoming less negative. So the velocity is increasing. Velocity is increasing. And that's just because it's negative and it's becoming less negative, so technically it's it's increasing. So acceleration in this case would be positive. Okay. Now, is the object speeding up or slowing down? All right. Now remember, we're talking about speed. And if you just take the absolute value of the velocity, you can see that we have a fairly steep slope and it's becoming less steep. So it's actually slowing down. Okay, so, oops, slowing down. So, okay, so again, just like when we were talking about whether things are moving away or moving toward home or the origin, there's a pattern here. We can tell if an object is speeding up or slowing down based on the signs of the velocity and the acceleration, right? So here, the velocity was positive and the acceleration is negative. It's opposite signs, so it's slowing down. Here the velocity was negative and the acceleration is positive, so it's slowing down. Notice the opposite signs on the velocity and the acceleration. All right, and same way up here. Now these the velocity and the acceleration are, in this case it was both, they were both positive. So the object was speeding up. Here they're both negative and the object was also speeding up. So notice when the velocity and the acceleration are the same sign, the object is speeding up, and when they're opposite signs, it's slowing down. All right, so I will meet you in the next video.